Wanted to learn the various hierarchy of system architecture? If yes, this video is for you. Welcome to BSpice. This is Rambala with you. In this session, we'll focus on Purdue model, architecture for process automation. So, Purdue model in the sense, we are going to dive deep on all levels, like right from level 0 to level 5. So this is the session. So this will be beneficial for freshers and intermediates, and of course will be useful for experienced professionals also, as we had covered few important aspects related to DMZ in this. Okay, so let's get started. Purdue model. What is Purdue model? Purdue model, also known as Purdue Enterprise Reference Architecture, that is, PERA, PERA, or ISA 95. It's a foundational framework used in industrial automation and control system. What for? To organize and segment enterprise and control systems, control networks. Okay. So in the 1990s, Mr. T.J. Williams, a member of Purdue University Consortium for Computer Integrated Manufacturing, published the Purdue Enterprise Reference Architecture PERA that provided guidance on the interface design between process control function and the enterprise functions. So very simple intro, and of course few more to add on. On the premise of PERA model. Okay, so the International Society of Automation ISA released a layer network model which describes the common vendor independent information flows which can be applied in any manufacturing or process production architecture, also known as ISA 95, International Standard for OT environment. Okay, so this is also just one info I want to put forth here. To address the cybersecurity concerns and ensure secure integration of OT and IT environment, ISA developed ISA 99, which is currently known as IEC 62443 series of standards on the cybersecurity of industrial automation and control system. If you are a first-time viewer, friends, in our BSpice channel, we have uploaded a detailed video on IEC 62443 series. If you are interested, you can watch. Okay. So let's continue with the intro. A few more to, the collection of IEC 62443 standards and technical reports is organized into four general categories called general policies and procedure system and component, which we already dealt in detail. You can watch and get benefited. Here we are not going to detail out that. The aspect of this discussion is more on this various level of architecture. Okay, so the part 62443 one that part 1 of the standard specify how the IACS asset should be organized into network layers like this based on the device function and requirements as shown here. To add on further, the industrial network architecture also involves provisioning of a OT DMZ. That's what I told. It may be useful for experienced professionals also. So the industrial network architecture also involves provisioning of OT DMZ zone. What for? To segregate the OT environment from the untrusted IT network on the internet. You got it, friends? So the Purdue model and IEC 62443 reference architecture are often referenced synonymically due to their direct relation. So they are regarded as the industry best practices and a widely adopted concept model for the logical network segmentation of industrial control system. So this is all about the intro, friends. Okay, now we will go into the details hierarchy. Level 0. So level 0 is about physical process sensors and actuators. This guy. Okay. So the lowest level of automation hierarchy includes physical process, supporting physical infrastructure, and defines activities involved in sensing and manipulating the physical process. As simple as that. This level, as you know, is called the field level. Okay. So correspondingly, sensors and actuators are often collectively called as a field instrumentation. So there are some, physical level of infrastructure, physical level. So one is a process equipment that is static. So this group of process equipment includes static process infrastructure, such as pipes, vessels, storage tanks, reactors, distillation columns, all these. Then we have a process equipment dynamic. So this group of equipment includes equipment which, if actuated or powered, is capable of executing dynamic and kinetic behavior. For example, pump, compressors, all these. Then of course we have our sensing equipment. In broader terms, this group of equipment capture various parameters of physical world, includes, pressure, temperature, flow, which is, related to our domain, instrumentation, right? So actuating equipment. Of course, an actuator, right? You see, converts a control signal into a mechanical action. Examples, includes valves, electric motors, steam or gas turbines, all these. So that's about the level 0, friends. Okay, now we go into level 1. This is of a regulatory control. Okay, so this level immediately adjacent to the field level hosts controlling equipment. These guys responsible for monitoring operating parameters and controlling the functions of physical process and equipment. Okay, so this level is called regulatory or basic control. So the type of control equipment includes PLCs, variable frequency drives, dedicated PID controllers, remote terminals, all these. The controllers basically interface the field instruments via analog digital input and output module. Okay, to continue this few more, in addition to the basic process control system, level 0 to 1 may also include an independent control system to carry out the safety function. In fact, in our BSpace channel, we have detailed out this. You can watch and get benefited if you're really interested on the safety system. See, the safety system, we call it as SIS or sometimes ESD, right? It provides a dedicated fail-safe operations of high reliability. It's used to protect against catastrophic consequences such as equipment damage, severe environmental impact, personal injuries, casualties, all these by shutting down the production application safely. So the SIS ESD is part of the independent protection layers to handle safety incidents as shown here. There are various independent layers of protection. This also we are covered extensively in our BSpace channel. You can watch and get benefited if you're really interested to this. So here in this session, we'll be seeing on a high level on the hierarchy. Right, friends. So now to continue with this, level 1 we have done. Right, now we go into the supervisory control. Okay, so supervisory control, here individual controllers contain a small amount of portion of control logic, right? Inside the controller, we have a control logic and it can control the process to achieve the local optimum at most, right? So as the title suggests, supervisory control, this level is involved in supervising the control function over a whole plant, typically done by human operators and engineers, right? So the main component of this level is a control room or the control center where operators monitors and control the plant through human machine interface HMI software, which contains a graphical representation of the process as shown here. Okay, so in level 2, few more are also there, few more items. The operators are notified of abnormal process condition or equipment malfunction that require actions to be taken by an application called an alarm system. So in fact, the alarm system also we have detailed out in our BSpace channel. If you are interested, you can watch the detailing of it. Okay, here the alarm management is the most critical function of a supervisory control. So the idea is what are all the items is part of the supervisory control. That's what I'm actually explaining. So alarm management is most critical function of the supervisory control, as the potential cause of an unresolved abnormal situation can be dramatic, ranging from significant financial losses to casualties. So the other system found at the supervisory level include typical components of distributed system. right? Control system, such as, configuration, maintenance and diagnostics, and control logic, equipment, database, batch management server, engineering desktop, all these. So a key element in the control system infrastructure is the engineering workstation, right? So a high reliability and sometimes, ruggedized computing platform equipped with software application and tools to program and modify the industrial process. So this is all about the level 2 supervisory control. Now we'll go into level 3, more of a operation management. Okay. So here in this at this level, reside the system that support the function involved in managing the workflow to produce the desired end products. You got it, friends? At this level, it has, the functions involved in managing the workflow to produce the end products, basically. Okay. So having said this, examples include the manufacturing system, execution system, we call it as MES, right? And also manufacturing operation management system, we call it as MOMS, right? So these systems take orders and business data from the corporate system to manage production scheduling, dependencies, ensure production capacity optimization, and scheduling dispatching of finished goods. You got it, friends? Yes. So it's more into operation. So this level also sometimes called, shared services, because it has applications and services jointly used by multiple plants, such as, centralized backup and asset management system, network management functions, file servers, and others. So this is about the level 3 operation management. See, to just add on, friends, among the pillar system hosted at this level is a plant information management system. You may be knowing, right? PIMS, we call it as a PIMS, also known as a historian. Yeah. So this is, shows the graphical user interface of one of the mostly widely used historian software. We call it as, OSI soft PI, right? So this is a typical, actually, example of, operation management. Okay. Basically what it does here, the PIMS, it collects and integrates the information about production process infrastructures from a multitude of different sources, including the local historian from level 2. So the historians use specialized algorithm for, lossy and lossless data compression to reduce the storage footprint, as well as a specialized software to enrich the data with context and visualize, statistical trends, something like this. Right, friends? So that's about the level 3. So far we have covered 0, 1, 2, 3, right? So to sum up, friends, OT zone. All these level 0 to 3 of the network reference architecture are collectively called OT zone or industrial zone. So the rise of automation leading to a higher efficiency has created an increased need for bidirectional flow between OT and IT. I hope you agree, right? So the OT zone is required to be protected from internet-enabled network such as the enterprise layer and any other untrusted environments like third parties. So this is achieved through provisioning of a dedicated perimeter network, also known as demilitarized zone, DMZ, which acts as a conduit system between OT zone and other external environment. So we will see that in the next slide. Okay, so level 3.5 here. So this is DMZ, demilitarized zone. OT-DMZ is a recent addition to the Purdue model. So similar to the conventional IT-DMZ, the OT-DMZ is a buffer zone where services and data can be shared between two networks belonging to different trust zones. So OT-DMZ is only non-functional level. It just provides an interface where the IT and OT words converge, right? Okay, so for this reason, OT DMZ level is frequently counted as 3.5 to highlight its extension to L3, level 3. So among the key functions of the DMZ is to enable the communication between the OT and the enterprise application in order to exchange the manufacturing and resource data. For this purpose, a historian from level 3 is fully or partially mirrored to a historian instance at the DMC. Okay, friends, I hope you got something about DMC. Of course, there are a few more to add on. So your DMC typically hosts, patches, antivirus server as well as application for securing, the file exchange between remote access to OT assets for third parties. For example, friends, in a plant, take a case of a Siemens, turbine management system, whatever is that system. So they can access our, industrial assets using through this only. They cannot directly go here and access. They have to come through this. That's the thing. And also, for a remote access, somebody want to have a remote access, it has to go through this. That's a point. When correctly implemented, no communication connection should directly traverse the OT DMC. All traffic should originate and terminate in the DMC. So, for instance, an historian data from level 3, or the first sent to the historian instance in the DMC and then sent to level 4 for consumption by business application. So, similarly, all communication flow from IT network, right, or internet first land in the DMZ and or then routed further, right? Okay, so this is about the DMC level 3.5. Now we go into level 4, enterprise network. So level 4, or we call it as the enterprise level, is where the IT system, application and function exist tasked with the management of the entire industrial system estate and business process. It's more of a business, right? So this is the level where that provides a business direction and orchestrates operations with the data flow up from the shop floor, level 1, and decision flowing down from the boardroom. Okay, so examples include ERP. You would have heard this, right? Enterprise Resource Planning, ERP. That's, drive long-term plan production schedule, material use, shipping, inventory level, logistics, business to business and business to customer application, all these kind of business activities, right? So this level also has various, supporting functions also, like R&D, security, operation center, all these fronts. So this is about level 4. Now we go into level 5. Okay, so friends, this is called as a cloud application. Level 5 or cloud level does not officially exist in Purdue model or IEC 62443 references architecture. However, we will discuss, to illustrate to the recent, technology or ongoing trends, as actually. I think you may be knowing this. See, one is the increasing desire of enterprises to reduce on-premise hardware footprint and reduce infrastructure maintenance costs. Instead of having your server, everything on premises, so this will be, upload available in cloud basically. So for this, various software as a service SaaS applications such as Office 365 and modern endpoint security solutions are examples of cloud hosted business application. In this regard, level 5 could be seen an extension of the Office network from here, right? L4. So another point is digitalization of industrial automation to achieve the next level of efficiency and operational excellence. We have been talking about digitalization, IIoT, all these, right? Yes. So this trend is also known as Industry 4, where the production and asset data are being directly fed into the so-called data lakes and cloud-hosted application for analysis and gathering insights, friends. So this is about the level 5 cloud application. So now we are done with all the 5 levels, friends. Just to add few more, here in the level 5, we also have a predictive maintenance kind of thing, right? See, among the most mature and widely adopted example of cloud-based application is predictive maintenance. So this is more of a proactive maintenance strategy that utilizes the condition monitoring application to detect various deterioration signs, anomalies, equipment performance issues, all these. For this purpose, the equipments are instrumented with additional sensors. As you can see, you have flow, temperature, all these discharge pressure. So everything will be embedded into the system. I mean the equipment, and wherein will get will able to gain the feedback, and also it could help to achieve the maintenance in a proactive way. Okay, so that's about this. We call it as asset digitalization, friends. Okay, so basically the asset data, those data will be used to create a predictive model to detect the signs of asset degradation. So this is about the cloud application. So now we have gone through level 0, 1, 2, 3, 4, 5. Okay. So as you know, level up to 3 is a OT zone. Right now, this 4 and 5, is more of a enterprise zone. So level 4, 5 collectively form a so-called enterprise zone. So this zone contains both system application which belong to OT infrastructure and pure office and enterprise IT system. Some infrastructure can be of W's, with examples being SOC and NOC, network operations center. So that's all I have for this session, friends. I hope you what do you call I hope this video is useful to you. So if you also feel the same, you can share your support, friends, by pressing the thumbs up button. Once again, friends, thanks a lot for your support. Keep supporting. See you soon in another interesting video. Take care. Bye bye.